Okay, good morning everyone, and welcome to the BBSim and Scalability Brigade for April 30, 2020. We have quite a few items on the agenda for today, so let's get started. The first topic I wanted to discuss is a change in the OpenONU adapter helm-chart that moves from multiple deployment to using a stateful set. This is the change. It is up for review, and basically the only change it does is deploying all the replicas as a stateful set. This seems to be working in my testing. Unlikely the only way I found to pass consistent replica ID to the pod is this ugly workaround. So I wanted to discuss it to get the general feeling if we should move in that direction or not. I've been using it in my testing for more than a week now, so I'm reasonably sure that it works across restart, device reboots, etc. Just I'm not very proud of this, but apparently Kubernetes, the next version of Kubernetes is going to release a new API to get this incremental ID in a better way. Are there opinions on whether to stay with multiple deployments or moving to a replica set?
I think this is the way to go. I can't believe this is not officially supported, and you are taking the replica ID by using a workaround. But when I searched the other threads, I didn't see a proper way. But it seems legitimate because people are using the same.
Okay, so I'll ask for some review and I'll create a Jira for this, and I'll ask for review both on the Volta and BBSim channels today. So just make sure we are all on the same page. Then we finally have the first set of job that checks the entire provisioning of a pod. So we don't only check for ONUs and ports, but now we also check for all the flows in Volta. We wait for them to be acknowledged nodes. We wait for all the subscribers to authenticate. Then we provision all of them. We wait for the DXC to be requested, and we check that an IP is assigned. Now, this is exactly the AT&T workflow. For now, that's the only one we are testing at scale, but at least compared to the Deutsche Telekom one, this one should push more flows into the system. So if we can scale up with this workflow, we should be good for Deutsche Telekom, where I think Deutsche Telekom will push more flows than Deutsche Telekom does, but won't go through people. So we may need to set up a different test as soon as BBSim fully supports the Deutsche Telekom workflow. For now, the one I showed you is a test job to verify that everything works with one NU and one phone port. When we go up to 64 NUs, everything looks to be fine for the equal flows and authentication. Seems like subscribers, not all subscribers manage to DSP. If we look at the numbers, the number of allocation is always around 25 or so. And when we check at the status of the devices in BBSim, we see that all of them have at least sent the HCP packets. Some of them never received one back. So this needs to be investigated. Honestly, I haven't had the time to look into it yet.
Is this with multiple ONU adapters?
No, this is with a single ONU adapter.
Okay.
Yeah, we don't have a full test with all the adapters, with multiple ONU adapters, because the 3 tests we set up are with 164 and 200 ONUs. And the one with 200 ONUs used to succeed with a single one. So we tried that, but I can try to move this one with 200 to use 2 adapters and see how it changes.
Matteo?
Yeah.
Do you see all the flows successfully pushed?
Yes. Yes and no, meaning that, again, if we go back to this job and we look in the console, we have a step that checks that the flows are in Volta. Let me just find it. Okay, we are checking for the news. We're checking for the flows in ONUs. Appears somewhere. We're checking for the ports in ONUs.
You see the Volta flows, but not ONUs.
Yeah, so we see all the flows in Volta, and we see all the flows in ONUs. But the issue that I'm seeing is that the flows in ONUs. Oh, okay. I'm not seeing that issue anymore, because sometimes the flows in ONUs are not all in added state, but some go back to pending added state, even though they are actually received by Volta.
Did Jono look into this? I thought we made some changes since last week.
There have been some changes, so it's possible that this issue is actually solved. So even in the 200 ONU cases, this seems not to be the case anymore. This is something I observed end of last week, and then I haven't had time to go back. So answering again to Serkant, yeah, I see the flow push. Okay, is there something else on this job, some other information that you would collect during the job? Or if there is anything else, just feel free to get in touch via the mailing list or Slack. One heads up on the pipeline is that it's getting fairly complicated to maintain the testing in Groovy and Bash. So I'm starting to look if it's possible to rewrite the pipeline using the robot framework. I spent a little bit of time looking at it yesterday, and it seems that it's fairly easy to do the same kind of check in a robot, and we should be able to have a more flexible test, more maintainable test, and possibly generating some better reports from it.
Matteo, we do have also some keywords to check for flows and check for other things. If you want, I can set up maybe a meeting with Hardik too. We can many of the tests.
Yeah, I was looking in the library. I'm leveraging what we have. I'm basically calling existing keywords.
Yeah.
But yeah, as soon as I have something that that is a little more elaborate than this, I'll share with people that have more experience than me, a robot, to get feedback.
Sounds good. Thanks.
Okay, I think this completes what needs to be said on the pipeline. The next topic we have on the list is the Deutsche Telekom workflow scalability running. I think, Andrea, you added this point.
Yeah, I've added it. It's just a simple question and discussion for the group. You mentioned it before that we could look at possibly having other operators' scalability tests. And I know that the DT1 is actually less flows than the AT&T, but I would still, if possible, create a couple of jobs. Maybe less than the existing ones for AT&T, maybe just a basic one that we know should always succeed, and one that pushes the number of the ONUs very high in order to test also the DT workflow. The same way you do it there with 200 ONUs, 500 and 1,000 eventually. If everybody's okay with that, I can create and upload a patch.
Works for me. We can maybe synchronize and decide whether we want to do that before or after we move to the pipeline. But maybe we can take this discussion offline.
Sure. Okay. Yeah, we can take it offline too. That's no problem. But it's just something that I'd like to do also because it could show us good results in a step manner. Because for AT&T we're pushing there are 3 flows more per subscriber than DT. So with the DT ones, we could maybe see consistent results earlier than with the AT&T scenario.
Yeah, and also would be good to have formal test that covers all the workflows.
Yep.
Okay, thanks. Then the next topic is something that came out of yesterday scale discussion, and is that to implement some kind of throttle in the ONU Discovery, so that if we don't have bandwidth to process X ONUs at the same time, we can just delay their discovery, so that we only process the amount of ONUs that we can actually sustain. And this will possibly make the system a little slower, but will definitely make it more stable. I think that the tricky question here is how to implement that. We had a very brief discussion yesterday in the brigade channel, and seems that the tricky part is to understand when the ONU adapter is done processing the ONU, so we can start processing the next.
Matteo, currently, are we 100% sure that throttling will help in this case? I think there's a lot of parts of the puzzle that we don't know yet of where the issues is actually. For instance, like we can improve as much as we want the core in terms of performance, but end-to-end remains as is, if not all the components are improved at the same time. If we have multiple ONU adapters running at the same time, are we still seeing the performance problem with the ONU?
I think if I understood correctly yesterday, but maybe someone from Reply can chime in. But if I understood correctly, was that when running on certain setup, components of the system started crashing because it was too much throughput in the system. Meaning we were trying to process too many ANUs, and so some of the components were going out of memory. Is that a right understanding of what happened?
Matteo, if I can jump in on this topic. Yeah, basically, just yesterday evening, we discovered that we had a problem on our side with OF agent that we were not using, unfortunately, the latest version. So once we have updated the OF agent, then everything works fine. So basically, the problem is solved. So we will be able to reach the 1000 ONU on the active state, so we know flow push it. So basically, at this point, we are on the same stage as you. So we didn't face this problem anymore, luckily.
Oh, okay.
So yeah, that's a really fresh news. So yeah. So we will try also on pushing the flows and see what happens, and then maybe we can come back to you if we face some problems. So yeah.
And is that with the multiple ONU adapters?
Yeah, exactly. We tried with the 8 ONUs adapter. Yeah, yeah, that's correct.
Yeah.
And what kind of time did you see for 1,000 ONUs?
Well, actually was we didn't actually look into it, but it was really fast actually. So we didn't measure it.
Including all of the service flow creation, or this is just the discovery part of it?
No, it was just basically the discovery. I mean the MIB, I was called initial MIB discovered. Yeah. Yes. Yeah.
Okay. So I guess the question is, do we still want to try this and see what effect it has on the system? Because we still can't, for larger numbers, I guess we still don't see completion of the test run, right?
Yeah, I think these are tools. Yeah, for the large numbers, as this test here shows, we're not quite at the completion at the test, and this is not even a super large number, being 200 ONUs. But I think this mechanism is more to protect the system when it runs on small setup. Meaning, if for any reason, I'm not arguing that anyone should do it at the moment, but if I try to run the entire system on my laptop and I try to provision 1,000 NU, I'll probably see containers being restarted because they are running out of memory and this kind of effects. Well, if we can limit down the number of NU we process at any time, we may not see, we may protect ourselves from these issues. Now, I think the question is, how much effort will that be for how much benefit?
So it seems like the mechanism of doing this throttling would be, I mean, if the OLT can just essentially have a window and basically just ignore any discovery requests if that window is full of ONUs processing. But as you noted at the beginning, the tricky part is when do I open the window up, right? So
Yeah.
how do I know an ONU has got to the,
Yeah, but
point where
basically
it's fully
when
configured, right?
Yeah, when do I free a seat on the train?
Right, exactly. And so I think the ONU state machine, I don't think, does that have a state that indicates it's fully configured with service flows, or it doesn't have a particular state for that?
It's tricky because it can have at least I'm thinking about the Deutsche Telekom workflow, for example. Until the subscriber is provisioned, the ONU will have no flows because there is no traffic that needs to come in from the NU before the data plane traffic.
Okay, and in the AT&T case, it's going to have
one equal flow.
Yeah. So is that a gate we could use to say that we can now open the window?
I'm thinking that there must be something before that, because that I think one of the once the the configuration of the NU is done, then yes, there is still some traffic going back and forth, but it's not many operation. So I don't exactly remember the name of the messages, but when the news just come up without close push, then they arrive in the Arizona MIB upload sync, whatever that reason stated. I'm thinking that could be when we free up the window, but I don't think the OpenONU adapter knows about that state at the moment.
Yeah, the tech profile download success would be a gating scenario, but it's complex for Turk Telecom when they start having multiple services distributed across multiple ONUs. So it gets complex. For DT or AT&T, it might be simple, but for operator like Turk Telecom, it's complex.
So should this throttling be based on the number of ONUs currently being handled by an ONU adapter, or could it be based on what is ONU adapter in terms of the resources that it is consuming, right? Like memory and processor, CPU cycles. Because if we base it on the number of ONUs being handled, this number would change from hardware to hardware, right?
Yeah, that's
running it on some powerful machine would give different results than on other machines.
Presumably that would go faster, I assume.
Yeah, my opinion is like any throttling has to be done by the component that is having problem. Yeah. So if the ONU adapter is cannot handle X amount, then it's the one that needs to throttle things.
Yeah, so it could set some flags like the readiness probe or something like that, saying that I can't handle any more load.
Yeah, as long as the OLT adapter can query that state of the ONU adapter, then it knows whether it can open a window or not, right?
Yeah, so
according to
looking that kind of a direction.
Yeah, and that seems reasonable.
Yeah, but instead, if we push, as Ken said, if we push this mechanism in the OpenONU adapter, that decides when to start the synchronization.
Right, but I think the acceptance of an ONU Discovery message happens in the OLT adapter, right? So
yeah, that's why I was naturally thinking to throttle it there.
Right, but as long as the OLT adapter can query the set of ONU adapters it's currently working on to see whether it should open the window or close the window, I think that would work.
The discovery is strictly the OLT. It's Plone. So it's mainly between the hardware OLT and the ONU itself. So part of the initial like discovery throttling would be actually on the discovery message. And that could be based on the context the OLT is in. So if the OLT just starts up for the very first time and is turning all of its pawns on, then that's a place, and that's the first startup, but it's also the lab test where you have to prove the worst case, the OLT coming up with everybody ready to go. So that's a place to throttle. Another one is making it smart. So when you get loss of a signal on a pawn on reception, so the entire pawn is going down, trying to optimize that use case. Another use case is when you have basically a service outage due to power failures. That's probably one not to worry too much about, because as various points in the pawn restore power, each ONU comes up at different rates.
Well, it depends if it's like a regional restoration of power as well.
Yeah.
It's like, so then it's like you've lost the pawn. And that all comes back, right? But,
yeah, and that's sort of a smaller one. And so that's all controllable on probably the OLT device adapter. Depending on the adapter, another optimization is in the actual polling of the discovery. So when you first come up and nothing's on a pawn and you're waiting for the first person to show up, you might as well poll discovery messages every couple of seconds, because that's faster and you're not using up bandwidth. But as soon as you get one or more.
What do you mean by poll discovery messages?
Basically, the OLT is responsible in Plum of going out and opening up a discovery window to find new ONUs.
Right, but that happens independent of the OLT adapter, right?
Yeah, that's actually in the OLT, but depending on but some OLT device adapters can actually control that rate. So as soon as you get one or more OLTs, decrease that polling interval to maybe 20 seconds or more. And that gives you a side benefit of fewer, you get a little bit more of a time span, but it also gives you a little bit more bandwidth. So it makes it a little bit nicer when you do bandwidth testing. It gives you that first quick start.
Yeah, that's kind of a refinement, I think.
I'm just trying to provide some.
Yeah, sure.
Yeah. Then on the ONU side, the ONU device adapter, when it reaches in sync, it actually it publishes a message on a bus that the other ports in the OMCI can listen to know what state it's in. So that can be made useful. When it goes in sync or when capabilities are discovered, those are all made apparent. So those are points in the ONU code that can be listened to watch it state within the ONU code.
I think ideally it'd be when the ONU is, all the flows are configured, because now once that happens, you know that you can kind of open up your window, right? Because now that you've opened up a slot basically.
Yeah, and then once you get up to the steady state, the main overhead outside of installing and removing services is if an audit every once in a while, even though you have mid-data sync being polled, you want to actually do a full audit at the MIB. That right now runs at a every 5 or 15 minutes. It'll try to do a full audit. That could be made smarter to only do that audit, that background, make sure the audit is true, and do that at if it sees like a loss of pawn. It sees some event that says, hey, let's do it only once an hour with some skew, unless the pawn goes down, when I might have lost a message, and then let's.
Right, isn't the MIB sync attribute an indication that you need to do an audit, or?
Yeah, but it's you have to make sure that you know, it's not a unlimited. It has a window. It's only 255 possible values. But it's always smart to go back, because sometimes, especially with different ONU vendors, when they initially come out with their OMCI stack, they may not count things correctly. You know, it's just it's general good practice to audit the MIB periodically, you know, regardless of the MIB data sync value.
Yeah, but the scale that we're looking at now is massive compared to what a single OLT needs to handle.
Yeah.
In terms of
Yeah.
that. I mean, that's just going to overwhelm the system, I think.
Yeah, and that's why I'm saying it might be something you want to do very infrequently if there's, you know, if the pond is stable.
Like never.
Yeah, well, yeah, never's a choice if you want to. If you feel that confident.
What could go wrong?
Well, we know what will go wrong if we do it too often.
Yeah.
Okay, so I don't know. I still think this is something we should explore, and maybe the OpenONU adapter can just publish a message on Kafka saying, "I'm ready, send me the next." And these can start as easily as a configuration parameter in the OpenONU adapter that says process at most this number of devices.
Yeah, and there's actually an event bus that's already written in the code. It can just be turned on pretty easily. So.
Oh, okay.
So if you just search around it in the OMCI MIB sync state machine or some of the state machine, there's actually a publish call. It's been a while since I looked at the code, so. But a lot of the infrastructure is already there. You just might need to tune it for the message format and when.
So just as looking back, I think originally, let's say you tried to get an idea of the ONUs per second rate that the system can handle, but that was kind of a long time ago now. And a lot of changes have happened in terms of performance and scalability, right? So is it worth trying some of those changes again, just to kind of see if we can pinpoint kind of a number of ONUs, discovered ONUs per second?
Yes, we can do that, but to actually have a meaningful result, we need to change the way we observe the system. Meaning that as now, the pipeline is not too smart, and it basically falls volt every 5 seconds. To have a meaningful measure of how long we take to enable one ONU, we need to measure that in some other way. Shrey has started working on publishing the, Praja added support in BBSim to publish events on Kafka when things happen. So we should be able to get these information from BBSim, and Shrey is working to integrate that with the pipeline.
Yeah, I think originally we weren't kind of looking at that in such a sophisticated way, right? So I think originally we said, okay, can I send, let's say, 20 ONUs discoveries, and then wait for a certain amount of time before the next 20, and see if the system holds up better by, you know, sending a bunch of discoveries and then waiting a while. And that waiting a while is key in terms of what the average ONU discovery per second would be, right?
Yeah, I can
schedule maybe that's too work.
Well, I can easily schedule another job for 500 ONUs, setting a higher delay, because now I reverted all the jobs to 200 milliseconds. because we were having basically the same result with 200 millisecond delay between ONUs and 1 second between each ONUs. I
was thinking more like a minute, something like that.
Yeah, I can easily schedule to whatever we want. I'll schedule a couple jobs, maybe for 500 and 1,000 ONUs with a way longer delay, and we'll see what happens.
Okay.
That should be fairly easy. Let me move. Okay. So we can use these to make some assumption of how the throttle would affect the system, and if it will actually improve the situation by a long shot, because this is basically artificially creating a throttle in there.
Yeah, so the delays make an assumption about how fast, we progress through to, adding the flows per ONU as well. So that would allow.
Well, that is not entirely true, because at the moment the pipeline will wait for all the ONUs to be enabled before programming the devices, the subscriber. So we can skew the execution until this point, but basically we'll wait. We'll sit waiting at this point for all the ONUs to be enabled, and then once that is, we'll check the other thing. But at that point, this should happen very, very quickly, because we skewed the processing before. We can make some assumption, because if I look in the 64 ONUs job, the ONUs are generally discovering less than 40 seconds. So I can use that as a time to skew the execution.
And that's for 64.
That's for 64.
Okay.
If we go to so this is, if we go to this, we'll have 16 coming up at each time, because when we set a delay in BBSim, we get 1 ONU on each CON port every X second. So we'll get 16 ONUs at a time. So most likely in 20 seconds they should be processed.
Okay,
and
so
we'll
then
have batches of 64 or 32. No, sorry, we'll have 32 batches of 16 and 64 batches of 16.
And then the delay between the batches is our assumed time it takes to process that batch to the point where it can have flows, right?
Yeah.
Okay.
So I'm guessing if it takes 40 seconds to do 64, if we set a delay of 20 seconds to process 16, should be safe enough. It's a guesswork. But
yeah, and if we're wrong, it'll eventually hit the point where it's not going to work, right? So this will slowly be overwhelming the system.
Yeah.
But then we can always adjust that time to be longer or shorter, right? Okay.
Yeah, let's get through these 2 jobs today, and then send some results out tomorrow.
Okay, sounds great.
Okay, the next topic is basically the next big task we are working on. That is to start collecting in the pipeline some profiling information. Yesterday, I started working on 3 patches to basically publish the ONU, profile image anytime we release an image. So I made some changes in the make files of the adapters. I'll move on with the discussion with Ken, but now if you specify this build profile equal true before make Docker build, then we also generate an image that is tagged with the dash profile tag and expose a pprof server on a specific port that can be used to query information in the system. In the same way, we added support in the Docker publish pipeline in Jenkins, so that happens manually. Hopefully, I'll have these patches in by the end of today, and we can start working on a pipeline to collect these informations early next week. It's important to note that this pipeline will have to be a different one than the one that we use to collect the numbers, because activating profiling will most likely make the entire system slower. So the numbers we get there will not be meaningful, but it will be helpful to know which part of the system is the most stressed. Is there any question here? Okay, great. The other thing I'd like to start working on in the near future is to really start integrating Jaeger tracing into the system. There was a presentation about Jaeger 3 or 4 weeks ago at the Volta TST. If you haven't seen it, I suggest to go take a look. Unluckily, I don't know how much bandwidth we'll have to work on that. But if anyone is interested in the argument, please reach out to me, and we'll figure out some way to get it moving.
Hey, hi, Matthew. This is Girish. Matthew, I think I probably pinged you, right, and regarding Jaeger. So if you need like working hands to probably work on this Jaeger, because I am looking at actually working on logging correlation, and I want to probably reuse something from Jaeger, but there are some places I think they would be similar kind of effort we need to do. So probably I think I can, if you need, I think any, you want me to work on Jaeger, I can probably work along with you on that.
Okay, that will be great. So maybe we can schedule a meeting early next week and figure out a strategy.
Yeah, sure.
Okay, I'll reach out to you offline to get some more information because I don't know much about what is happening in the log world, so maybe I'll need to get up to speed on that part.
Yeah, yeah, sure. Maybe I will probably, I think, try to explain you, right, how we are proceeding in logging, and then we need to probably find a common path, right, so that we use whatever is possible across these two, the tracing and the logging.
Yep, that will be great.
Yeah, thanks.
Cool, thanks a lot. Okay, and the last point on the list, Meyer sent out a patch that we discussed last week that separate flows, group, and meters from the logical device in an RW4, and he was asking for opinion and reviews. Since he wasn't able to join today's meeting, I will suggest to just go through the Garrett reviews or discuss it in Slack. But if people can take a look at this page.
And is the definition of a logical device in this specific case, is that always an OLT?
The logical device is a combination of the NNI on the OLT and the UNIs on the ONUs. It's the one that gets exposed up to ONUs.
I see. So this would be on a also on a per ONT basis potentially, right? If we're thinking of the ONT with a single view.
There's a one-to-one mapping between a logical device and an OLT. Like Matteo said, the logical device, the ports on the logical device are the NNI ports on the OLT and the unique ports on the ONUs. But in all cases, it's really a one-to-one mapping to an OLT.
Yeah. Okay. Understood.
I might have forgotten the context of what this was trying to address. Maybe it was discussed in previous meetings. So what is this trying to address?
So if I'm correct, the problem was that if we keep the flows for all the ONUs in the same logical device, then anytime we lock that device, we're basically serializing the operation for different ONUs. While moving the flows outside of there, we don't have this concurrency problem anymore.
Okay, got it. Thanks.
Yeah, I review his patch, and it's a good patch. One comment that I have, and I think I'll discuss with me here. It's the change that he made. It's a model change in the sense of instead of having flows within a logical device and eventually within a device itself, it's moving the flows, the meters, and groups outside of the logical device. And the idea behind that is once you move it outside, and then you have your parent being the flows, and then your child being the device IDs followed by ports, and then where you have all those flows, then you can lock individual ports in that structure and update. So that definitely increases performance. So my comments with him, it's a really, do we want to limit that change to the core only, or do we really want to do a proto change of the model itself? Like reflect that change in the proto so that any single component that use flows, they will abide to that structure, which will increase performance across any component that use flows.
Yeah, that has a potential advantage also for the time we read the devices, because the size of that response will decrease by a lot if the flows are not in that structure anymore.
Yeah, exactly. Yeah.
Yeah, that seems fair to me. Seems like you guys are on top of it, so I'll just sit on the side of this one. Okay.
Is there a Jira explaining this problem?
Good question.
I don't think there's a Jira.
Yeah, I don't see the Jira ID.
But it's a simple case in the sense of today, if we have to update a flow, and there are different ways to do that. There's improvement that can be done still with the current model. You don't have to really move things outside. things can be done with the current model. But the whole idea is instead of locking the entire device to update the flow, if you have a lot of concurrent flows, and those flows will be processing in serialized way. But if you move those flows outside and put the lock on each port per port, then you can process them in parallel. And you could argue that you could still do it with the current model and just change the locking mechanism. So that's a discussion with Mahir.
Okay, yeah, thanks. Now, why I ask this is because the change that is being sought out is a pretty fundamental change, right? Because logically the flows belong to the logical device. Now we're trying to take it outside the logical device.
It will still belong to the logical device, but in the model it will be outside. In a way, it's really moving it outside, just purely for performance reason. And I could argue it could remain inside and change some of the proto definitions. For instance, looking at the protos lately, a lot of the definition of protos were using the repeated fields, which means inside the code, it's an array, instead of using the map, which will make things a little bit more directly accessible. So there's some changes in the protos that in any case we need to do.
Okay, thanks.
But okay. But you're right. Maybe we need to have a Jira to explain this.
Yeah, I'll ask Mahir to create a Jira. And we can kick off a bigger design discussion if needed. Okay, is there anything else we need to discuss today? I think it was a pretty good meeting so far.
Yeah, I'm wondering how we will proceed about the multiple OLT case regarding having one core per OLT device. And when we have multiple OLT devices, then we need to replicate the cores. So, you know, there were some debates yesterday meeting, but we doesn't have a agreement yet, I guess.
Yeah, we may need to kick off the discussion again. I think we can at least start the discussion over an email thread, and I would say we should address all the commands that are in the scale document that is available for everyone to look at in the design document.
Yeah, and that was actually, I asked a question in that document about what are the implications on scalability for a large deployment of Tibbet style OLT devices. So basically I have a single NNI and a single PON port.
Yeah, in that case, I mean, if you have a single NNI and a single PON, I guess you're talking about the Tibbet style OLT.
Yeah.
In that case, we may not need to strictly enforce one OLT, 1 volta stack, because that will support what, 64 ONUs.
Right, but if you know, further down there's discussion of what what a pod is defined as, right? So in terms of deployment, on nodes and resources used for a pod, it seems like that would massively increase the requirements on CPU. Well, no. I mean, I'm just asking the question. I haven't thought through the whole thing.
Yeah, no, that's definitely an interesting question. No, I don't think that that Vault itself consumes that much CPUs or memory if you're not stressing the system. And I think with 64 ONUs, you'll be able to get away with a single adapter, so it won't have the 10 CPUs problem we were discussing yesterday. So maybe replicating horizontally the Volta stacks is not a big issue. But we need to reach an agreement on how we want to deploy this bigger scale, and then at a certain point we need to add support in the pipeline to do that. But that will be a little bit of work.
Yeah, and there's questions in this model around how do I support type B protection? How do I support NGPON2? And what's the optimal architecture so that it can support those kind of features as well? But okay, but that's a bigger discussion. Yes.
Hi, I have one basic question on this. We know that the ONU adapter could not scale up because it was single-threaded and Python was slow. But why are we saying that we need to run only one OLT on one core? Can't the more number of OLTs?
And that is a decision that was taken by the TST at this point, I think 5 or 6 months ago, to simplify things. I don't think that a strict requirement. I mean, the software still supports multiple OLTs, and in our scale job, we have one job that runs with 200 ONUs, 100 per OLT. You can see we deployed to BBSim in this test.
And I think it's also a deployment option. So what we will implement will definitely let us assign multiple OLTs to a single core. So it is just a model. If you want, you can put one OLT per pod, or you can put multiple OLTs per pod. That will be the option. That is what I am thinking.
Yeah, I think that is what is the part given on this side. So what we were thinking is, would it be worth to have some jobs where we test multiple OLTs on the same core itself or on the same stack, and at least see what happens?
Yeah, we have this test that runs with 2 OLTs, 100 ONUs on each OLT for a total of 200, and is succeeding reliably. So the core is totally capable to support multiple OLTs. I think that the limit is more the total number of ONUs. So you can basically decide whether you want to run with one OLT at full scale with 1,000 ONUs, or if you want to use 5 OLTs with 200 ONUs each, because that should give you very similar results.
Yeah, it just seemed like in that document that you pointed out, it seemed like the options were being limited in terms of number of OLTs per pod.
Yeah, I think that this is the assumption that that was made in the TST, but there is nothing in the code that prevents you to have multiple OLTs for the same core. And honestly, I think this is a deployment choice that different people can take in different ways.
Yeah, like that would be better.
So I think if we are talking about a plugin OLT, then it wouldn't make sense to me to deploy an entire Volta stack to support 60 devices. Okay, we are at the top of the hour. So unless there is anything urgent, I would wish a good day, evening, afternoon, depending on where you are, to everyone. And we can keep talking on email, Slack, or a group here next week.
Okay, thanks a lot.
Thank you. Bye-bye.
Bye now.
Thanks, everyone.
Bye.
Have a good day.